Hey there, welcome back. So today we're going to be taking a look at, this is a teeny tiny board, but it's there so that we can make sure that we know when we're deadlocked. So we're having the board know when there's no more matches. Right now it's just going to print out a little message down here saying that it's deadlocked, but next time we're going to be able to expand this to make it actually reshuffle the board. So at least it knows it's deadlocked. So yeah, let's dive right in. Getting started here, we're going to take a look at our grid script. And this is where we're going to be doing pretty much all of our logic here for detecting a deadlock. Today we're just going to have a board that can detect if there's a deadlock, and then we'll make it so that once there is a deadlock, the board shuffles itself. That'll be the next part. So let's open up the grid script here, and let's take a look. Actually, before I do that, let's talk about the logic behind this. So when you're detecting a deadlock, what you want to do is you want to detect if there are any possible matches anywhere on the board. And to do that, what you can do is make a copy of all these pieces, and then you only have to check two directions. So if I were to take, say for example, this piece here, this piece can be the end of a match 3 that's horizontal like this. It can be the middle, or it can be the left end. But any of those types I can find by just swapping it up. And same thing if I swap this piece up or this piece up. So you really only need to swap up. You don't need to swap up and down, because when you swap the two pieces, even if it would need to go down to complete the match. So let's see, where's one on here that would make a match by going down? This one. Even if this would need to go down, if I move this piece up, it moves that one down. And so long as I'm taking every piece and moving it either up or either left or right. So you only have to do two directions. So essentially what our deadlock is going to be is moving a piece up, or let's do up and right. Moving a piece either up or right. And then after we move it, we're going to check the entire board again and see if there are any matches. And then we'll move it back. And then, tell the system if there's a match or not. And then we'll do that very quickly through the entire board. And it sounds like it might be system, like a big drain on system resources. It's really not. And this is also the logic that goes behind reshuffling the board, because we need to know where we should swap stuff. And it's the logic that's behind generating a hint, which is one of the big things with games like Candy Crush and so forth. So those are the two main things. We're going to make a copy of the entire board. We're going to save that in another array. We're going to swap the pieces. So we're going to need a method to swap in a specific direction. Then we're going to swap them either up or right, and then we're going to check the entire board after we swap, and then we're going to detect if there's a match, and then we're going to iterate that over the entire board, and it's going to be able to tell us if we have a deadlock or not. So let's get started here. The first thing I want to do is I'm going to jump to my find matches array, and I'm going to make some changes to that. So the changes I'm going to make are nothing to change the logic behind how it works, but it's changes to make it more flexible so that we can use it in other circumstances other than just how we're using it. So right now our find matches array will go through the all pieces array and check the all pieces array. I think it checks left and down. Yeah, it checks left and down, and then adds them to an array. I'm going to add a couple extra overloads to this. So an overload would be other options that I can have for what find matches might be. I'm going to add an optional parameter, which is query. I'm going to default that to false. Now when you add a parameter and already set it in here, if you call find matches and don't have that parameter on it, then it's just going to go with whatever the default value is. So this query value is for me to return a true or false value to see if the board is full or not. And this is one of the reasons that Python is a really cool language, because you can take a function that would otherwise be a void, and you can turn it into both a void and something that returns a value. It's kind of cool about Python. Well, and GDScript is Python derivative, so. So query is false, and then we're going to do another one for what array we want to use, because we want to use that clone array and not the actual array. So we're gonna say array is equal to all underscore pieces, and so by default the array that we're going to use is going to be all pieces. But that means that we need to, instead of referencing all pieces here, we're going to change each of these to be array, which is using that parameter. So I'm just going to copy this and kind of go through here really quickly. And I'm going to change all of the references to all pieces to say array. It won't change any of our functionality because we have those defaults. So I'm just going to run through here. I might even speed this up. Okay, so I went through and I changed the all pieces references in here to be a reference to a generalized array. That way I can use this with our clone array, and I have this query set to false. So here's where the query is going to come in. Before I do anything with the pieces, after I check them, before I do the match and dim or add to array, I'm going to check to see if query is true. So if query, I'm going to return true, because that means that there is a match. If I get to this part here, there's a match on the board, and I don't need to add anything to the array. I'm going to do the same thing if there's a match down, and so I'm going to say if query, return true. I'm also, after we go through everything, if we haven't already returned out of the method, then that means that we didn't find a match. So I'm going to say if query, return false. This way we don't run the get bombed to pieces method if we have something that's going to be deadlocked, and we also don't start that destroy timer when we don't need to. So we've turned this find matches method here by just changing a few things into something that we can use for another bit of code without needing to needlessly write our code again. So there we go. Okay, so now I'm going to make a reference to that clone array that I said. I meant to do that first. So way up here where I make my all pieces array, I'm going to make another. So var clone array, and I'm going to set that equal to an empty array to start. Then I make the all pieces array. I'm going to do the same thing for the clone array. So clone array equals make 2D array. So now I have a two-dimensional array that's just completely empty. That's the clone array. All right, cool. So now let's talk about those three helper methods we said that we were going to make. One to swap any piece with another piece in a given array. So we wanted to only do that in the clone array. Another one to swap the piece and then check to see if there's a match on the board. And then another one to do that to everything. And I'm going to add another method which is going to make the clone array exactly equal to the all pieces array. So I'm going to go all the way down here to the bottom. It just makes sense for me to do this. I don't know why, but it seems to make sense to me to do this down here. So first thing I'm going to do is I'm going to make a function that I'm going to call copy array. And this is going to take an argument because we need to know what array. Actually, we don't, because I think I'm only ever going to copy. Well, I might as well have an argument. So I'm going to call this array to copy. And I'm going to say for I in width. Actually, let's make a little variable here. So var new array for I in width, for j in height. I'm going to say new. I'm even going to make that new array a 2D array equal to make 2D array. So I'm going to say new array ij is equal to array to copy. So we're just copying the array, and then I'm going to return that array. So return new array. All right, cool. I'm going to save that. And this is just going to be a little function that only works with two-dimensional arrays because of the way I have it set up, but I'm really only dealing with two-dimensional arrays in this, so I think that's okay. So first, I'm going to want a method to switch any two pieces. So this is going to be function switch pieces, and this is different than the swap pieces method I made for moving pieces around. This is going to take a few arguments. We need to know the place that we want to swap them at, which is going to be a vector 2 row and column, or column row, and then a direction we want to swap with, and I'm just going to have that be a vector 2 as well. So like if it's 1, 0, it's to the right one and then no y. And then an array to use. So I'm just going to call that array. And I'm going to say if, so first I want to make sure that the place that I want to swap it with is in the grid and is not one of those restricted filled spaces like the concrete or the blank spaces or the chocolate. So if is in grid, and is in grid, I think it takes a column and a row. Place.x, place.y. Actually, it should be place.x, so it's the place we want to swap with. Plus direction.x, place.y, plus, so it's the place where we currently are, plus the direction we want to go. So if it's in the grid and not restricted fill, okay, and restricted fill, I think this one actually just takes a vector. I'll check on that. So let's just say, let's assume it does for now. Place plus direction. All right, and then I'm just going to add a pass here. Let's let that think for a second. Okay, let's go up and check on our restricted fill. Yep, that takes a vector and is in grid. Where is in grid? Am I missing it here? I've got is in array, but that's for checking stuff. Remove from array. Spawn blocks, match add. There it is. Is in grid. Nope, is in grid takes a vector, so we're good there. That saves us a little bit of time. All right, so I'm going to say this is just place plus direction. Place plus direction. All right, so we're checking to see if the place that we're looking at is in the grid. And let's also check in here. Let's also check in here. If all of this just with place instead of not place plus direction. I'm going off of my notes here. I'm going rogue. This might be bad. We're going to find out though. Nope. There we go. Okay. And so then this should just be place. So I want to make sure that not only is the place plus the direction the one we're swapping with, not one of the blank spaces, but the space that we're swapping isn't a blank space. Pretty sure that makes sense. All right. So, so if it's in the grid, then I'm going to make a little holder here. I'm going to call this var holder, and that's going to be equal to array place.x plus, so it's the one that we're going to swap it to, and then place.y plus direction.y. So that's a little holder. Then I'm going to say array place.x plus direction.x place.y plus direction.y is equal to array place.x place.y. So let me just comment this out so that I'm making sure to explain everything that we're doing here. So first hold the piece to swap with, then set the swap spot, it's kind of fun to say, as the original piece. And then after we do that, we're going to then set the original spot as the other piece. So to do that, I'm just going to say array place.x place.y is equal to holder. So I'm setting it equal to the other one. And then I can get rid of these pass statements here. All right, cool. So that switches pieces. Now I want another function to switch pieces in a specific direction and then check the board. So this is going to be function switch and check. And then this needs to know what place we're going to switch, the direction we're going to switch, and what array to use. So we're still using that place, direction, and array. So I'm going to say, I don't need to check to make sure that any places are in the right spot because I'm already doing that in switch pieces. So I'm going to say switch pieces place direction array. And then after I switch the pieces, I'm going to say if find matches, and here's where that overload comes in. I'm going to give it a query. So I'm going to say true for query. So this means it's going to have those return statements active. And then I'm also going to use the array that I'm passing in. So if that's true, I'm going to return true. But before I return true, since I just switched those pieces, I'm going to switch them back. And actually, this is kind of the weird part. In order to switch them back, you don't need to reverse anything. It can just be the same. So let me show you. It should be okay if I press play. All right, cool. So if I swap this piece with that piece, so now I've got the green one here and the pink one here. If I want to switch them back, I don't have to say to swap this one the other direction. I can instead just say swap the same piece in the same direction and it'll put them back where they were. So if I swap the pink one to the right, and then if I swap the green one to the right, it puts them back. So I don't need to do anything fancy to change it. I can just leave it the same. And if that's not true, then I'm going to return false. All right, get rid of that pass there. Cool. All right, so we've got 3 of our 4 little helper methods here. I feel like this is a really dense episode, which is why I save this for towards the end. Oftentimes people want to talk about, like, how do you make sure that there's not a deadlock? Well, it's kind of complicated because you got to have like this fake array that then checks everything for every possible move. It's a whole thing. Anyway, so the last thing that we're going to do is I'm going to create a function to tell if the board is deadlocked or not. And this is going to be called isDeadlocked. And the first thing I want to do here is I want to take the clone array and set that equal to copy array all pieces. So first thing I want to do is create this clone array. Create a copy of the all pieces array. Then I want to look at every piece. So for I in width, for j in height, I want to, let's switch right. Let's call it switch and check right. So I'm going to call switch and check, and I want to switch and check vector to ij, which is the place, the piece I'm checking. The direction, if I'm going to go right, is going to be vector to 1, 0. And then the array I'm going to use is the clone array. And what I want to do here is I want to say if switch and check So if I get something true back from that, then I'm going to return false, because that means the board isn't deadlocked. If this switch and check returns true, the board isn't deadlocked, so I'm going to say false to whatever's calling this. And then I'm going to do the same thing with switch and check in the other direction. So I'm just going to copy this, paste it there, and now the vector I'm going to switch it to is going to be 0, 1, which is going to be up. And I'll comment that. Switch and check. Check up. All right, cool. Now, so if we go through everything and we check everything, and we didn't return, then that means that we're going to return true. All right. Now, testing this is not super easy. So what I'm going to do is I'm going to find my after refill method. So after everything gets refilled, here, I'm going to add, before I do any of that is moves, I'm going to say if is deadlocked, then I'm going to print deadlocked. So that's all I'm doing. Now there's a few things that I'm going to need to do to make this work the way I want it to. Over here in my grid script, I'm going to set my preset spaces to be nothing. I'm going to set my ice spaces to be nothing. And I'm going to change the size of my board. The smaller the board is, the more likely you are to have a deadlock. So I'm going to make my board 4 by 4. I don't want to go too much smaller than that, because you could create something where it's impossible to make a match, like a 2 by 2. 3 by 3 you can still make a match, but it's not great. But 4 by 4 will at least get my point across. And I'm not going to change my X start and Y start, so it's going to look like it's kind of down here in the corner. If you don't want it to be in the corner, but you still want a small board like that, you need to make sure that you're manipulating these two values. All right, so, oh yeah, and I want my empty spaces to be nothing. Okay, that should be okay. Let's hit play and see if it barks at me. Okay, cool, it barked at me. Oh, okay, yeah, I forgot that I had to change this. So this, when I was checking to see if preset spaces dot size is greater than 0, I need another check. If preset spaces does not equal null, and then I'll put the rest of this in just another tab. There we go. Because I got rid of those preset spaces. I forgot to actually check to make sure that I was doing that right last time. But yeah, so let's try this again, see if it barks. Yep, barked at me again. Where at? What did I do? This is in array. Oh, for I in array dot size. So let's say, yeah, let's say if array is not equal to null, and then I will indent that over one. Cool. Glad I'm finding all of these errors here. Yep, still gonna bark at me. Spawn ice. Man, I thought I had this. Okay, so I must have did something wrong. So let me go here. Oh, I used the. Good lord. I'm just gonna set this to 0, and like, hopefully it'll know that I did something to it. All right, well, whatever. Let's go back to where we were barking at. So for I in lock spaces dot size, if I spaces is not equal to null, and I'm going to do this to all the other ones too, otherwise they're going to bark at me. So I'll just grab this, copy, lock spaces, and then concrete, And then this should be concrete spaces. And then this should be slime spaces. And then change that ice to slime. All right, cool. Not slime spaces. All right, cool. So let's see if this barks at me again. All right, cool. And I got my teeny tiny grid down here. Now, even with a 4x4 grid, it can take a little while to get a board that would have a deadlock. So, yeah, see, like right away, got all kinds of matches here. Another match, another match. So I might need to fast forward this just to check to make sure that we get a situation where there's a deadlock. So, see you in a second. Okay. Now, does it know it's deadlocked? No, it does not. Why does it not know it's deadlocked? Oh, okay. So I forgot to, I switch them back before I return true, but I forgot to switch them back before I return false. So I'm just going to grab this little here, copy this, and then paste it here. That way, and this is why we're using a clone array and not the all pieces, because that would have wreaked havoc on everything that we have. So let's hit play, and let's try this again. So, all right. And I might fast forward again, because I can already see there's a few more matches on the board. It is good that we're not seeing it say that there's a deadlock when there isn't one, so that's a good sign. And there we go. Our board is deadlocked. We have no current moves, and it knows it's deadlocked right down there. So, yeah, there we go. Next, what we're going to do is we're going to make it so that it can know when it's deadlocked, and then once it's deadlocked, it will find a new home for every piece, and then move those pieces there. So, feel free to ask any questions in the comments down below. You can follow me on Twitter to find out when I post new videos. You can join my Discord, all kinds of great people in there. And yeah, everybody out there, have yourselves a wonderful day. If you enjoyed this video, consider giving a like, subscribing to the channel, or telling a friend who might be interested. Also, please consider following me on Patreon. For as little as $1 a month, you can earn access to tangible rewards, like early access to videos, backer-only videos and series, polls for future topics, streams, and even individual tutoring sessions. You can find a link to that in the description. And as always, have yourselves a wonderful day.